All right, let's go ahead now and go over number 7. For number 7, we're looking at half angles. But before we can really attempt to do the half angles, we have to kind of look and see what information we're given about the problem. So in this problem, we're given that sine of theta is negative 8/17 and cotangent is less than 0, meaning cotangent is negative. So you have to think in which quadrant is cotangent negative, aka tan. Where's tan negative? Tan is negative in the second and fourth quadrants. And then where's sine also negative? And that happens in the fourth quadrant. So your reference triangle is going to look like this. And you're going to be given opposite over hypotenuse, so 8/17. Of course, this is our negative 8 because we go down 8. And then we're going to use the Pythagorean theorem to find that this is the square root of 15. So now that you know that that's the square root of 15, or excuse me, 15, not the square root of 15. Sorry about that. Now you can take a look and see for our half angles which quadrant we're going to terminate in. Because remember that we are only concerned with where theta over 2, or the half angle terminates. So where does, let's get our theta out here, theta over 2 terminate? Okay, and to figure that out, we are going to take our original range, which was from 270 degrees up to 360, and we are going to half it. So if we divide 270 in half, we get 135. And if we take half of 360, we get 180. So in which quadrant are we between 135 and 180? And that is in the second quadrant. So our half angle is going to terminate in the second quadrant. Now in the second quadrant, we know that sine is positive and cosine is negative. So when I take my half angle, sine of my half angle, I know that sine is going to be positive and cosine is going to be negative. So I'm going to use my formula for half angle, which is the square root of 1 minus the cosine of the angle of theta over 2. Now I know from my reference triangle that cosine is adjacent over hypotenuse, which is 15/17. So I'm now going to substitute that in, 1 minus 15/17 divided by 2. Now I'm going to go through and find a common denominator now. If I find a common denominator, my common denominator is 17. So this is really 17/17 minus 15/17. So when I simplify that, I'm actually looking at 2/17 over 2. Now dividing by 2 is the same as multiplying by 1/2. So again, I'm going to multiply by 1/2. Dividing by 2 is the same as multiplying by 1/2. So now when I simplify that, I'm going to get the square root of 1/17, which is really the square root of 1 over the square root of 17. And if I rationalize the denominator, I will get root 17/17. So that is the sine of theta over 2. Now I'm going to do cosine. My formula for cosine is 1 plus the cosine of the angle. So everything is going to be the same, except for I'm going to do 1 plus. So I'm going to be left with negative 1 plus 15/17, which is actually going to be 17/17, and 17 plus 15 is 32. So that's negative root 32/17 divided by 2. Dividing by 2 is the same as multiplying by 1/2. So when I do that, I can reduce before I multiply, and 32/2 can reduce to 16/1. So that's really the square root of 16/17. The square root of 16 is 4 over root 17. Rationalizing the denominator would give me 4 root 17 over 17, and don't forget to carry that negative sign across. So the cosine of the half angle is negative 4 root 17 over 17. Okay. Number 8, now we're going to solve each of our equations. And I know that the biggest decision here is, do I have to get it equal to 0, or can I just get the functions of sine, cosine, tangent, etc. on one side and the numbers on the other? So we're going to talk about the differences in types of equations for equation. And again, these are solve each equation. Another direction, solve each equation. Okay? So in this case, we're going to look for actual angle or radians. Okay, those should be our answers. So for this first one, notice that I only have a sine. There's no sine squared, there's no sine cosine. That is a pretty good indication that I'm going to be getting the function on one side and the number on the other. So now I'm going to be left with 2 sine theta plus 7 equals 6. Subtracting 7 will give me 2 sine theta equals negative 1. Divide both sides by 2. And now I know that sine of theta is equal to negative 1/2. So now you have to think, on your unit circle, where is sine of theta equal to negative 1/2? Well, you know that sine is negative in the third and fourth quadrant. So since sine is negative in the third and fourth quadrant, I'm in radians right now. Okay, so in the third quadrant, you're going to take pi. Your reference angle here is going to be pi over 6, and you're going to add pi plus pi over 6, and your first solution then would be theta equals 7 pi over 6. Okay, because that's third quadrant. Here's pi. So I'm going to add my reference angle of pi over 6, because I know that 1/2 is pi over 6. Okay? And then in my fourth quadrant, I'm going to take 2 pi, and I'm going to subtract pi over 6. So when I do that, I'm going to be left with 11 pi over 6. So those are my two solutions to this equation. And again, I'm left with an angle or radian. In this case, radians, because I'm in radians. Now, for my next equation, notice I have a squared. Again, that's a pretty good indication that this is going to be some type of quadratic. So I'm going to want to get everything on one side, which means I'm going to want to subtract root 3 tan x. And if you divide out that tan on both sides, you're going to lose some possible solutions. So you're going to definitely want to just subtract root 3 tan x. So I'm going to be left with tan squared x minus root 3 tan x equals 0. Now for some people it helps at this point to take out that tan, because when I'm factoring it can get confusing. However, if you just want to notice that both of these have tan in common and you can factor that out, you're going to be left with tan x minus root 3 equals 0. Okay, so now you know that since this times this equals 0, that either means that tan of x equals 0 or tan of x minus root 3 equals 0. Okay? Now you need to think to yourself, on the unit circle, where is tan of x 0? Well, tan of x is 0 at 0 and pi. So therefore, those are two of my possible solutions, 0 and pi. Now, I have to add root 3 to both sides, and you have to think to yourself, where is tan root 3? Positive root 3. Well, tan is positive root 3 at pi over 3. And then again in the third quadrant, which is pi plus pi over 3, which is 4 pi over 3. So your other two solutions from here are pi over 3 and 4 pi over 3. So those are your four possible solutions. All right. So again, had we divided out that tan x, I would have only been left with this equation right here, and I would not have gotten the 0 and pi. So you definitely want to keep it in there and treat this as a quadratic and factor it. Okay, let's take a look at number 9. 9 has a tricky one on there, letter B, but let's go ahead and first address letter A. So now we're in degrees because it tells us that our domain is from 0 to 360. So therefore now, notice you have a sine and a cosine. Whenever you have two different functions, it's usually a pretty good indication that you're going to have to factor something out. Also notice you have a double angle here, so you're going to have to use the double angle formula. So let's go first, go ahead and use our double angle formula. And if we use our double angle formula for this one, I'm going to be left with 2 sine of x cosine of x equals cosine of x. And again, you cannot divide cosine of x here. If you did that, you would lose possible solutions. So I'm going to subtract cosine of x from here, and I'm going to be left with 2 sine of x cosine of x minus cosine of x. Now, can I subtract cosine of x minus cosine of x? Definitely not. That would be like taking x times y minus y and saying that that was equal to x. That is not true. You cannot do that. Okay? So now I'm going to factor out a cosine of x. So I'm going to be left with cosine of x times 2 sine x minus 1 equals 0. So now since this times this equals 0, I know that either cosine of x equals 0 or 2 sine of x minus 1 equals 0. So now you have to think to yourself, where is the cosine of x 0? Okay, on your unit circle, where is cosine 0? And cosine is 0 at pi over 2 and 3 pi over 2. So those are your first two possible solutions. Now, again, we are now in degrees, so I'm actually going to state those as 90 degrees and 270. So those are two possibilities. So I'm going to go ahead and write those down. Now I'm going to go to my other equation. I'm going to add 1. 2 sine of x equals 1 divided by 2. And sine of x equals 1/2. So now you have to think, where is sine of x 1/2? Sine of x is first positive 1/2 at 30 degrees. So that's going to be another possible solution. Sine is positive as well in the fourth quadrant. So I'm going to subtract 360 Sorry about that. Sine of x is positive in the second quadrant, not the fourth quadrant. So I'm going to take 180 and subtract 30, and I'm going to wind up with my other solution of 150 degrees. So now my four solutions are 90, 270, 30, and 150. All right. Let's take a look at my next problem, because with this one, you see that there is a double angle here. However, if you try to substitute a double angle in here and square it, you're going to be left with a really, really long quadratic. Okay, and you don't have to do that. This one, you're just going to use the concept of multiple angles. Okay, and what do I mean by that? Well, let's go ahead and just solve this one, just as if cosine squared was an x. So the first thing that I would do is I would add 3. I'd be left with 4 cosine squared of 2x equals 3. Divide both sides by 4. You're left with cosine squared of 2x equals 3/4. Take the square root of both sides. When you take the square root of something in an equation, remember you are left with the positive or negative version of that. So this is actually positive or negative root 3 over 2. So now, here's the dilemma. You know that the double angle is equal to root 3 over 2. So we're going to go through the unit circle, and we are going to find all of the places where 2x is equal to root 3 over 2. Okay? So where is 2x equal to root 3 over 2? Positive and negative. And we're looking for the cosine value. So the first place that happens is at 30 degrees. Okay? The second place that happens in the next quadrant is my reference angle of 180 minus 30, which is 150. Then 180 plus 30, which is 210. Then 360 minus 30, which is 330. And I can't stop there because I know that this is multiple angles. And this is what 2x equals. So when I divide these in half, I'm going to have another rotation to represent. Okay? So now I'm going to keep going. I'm going to take 360 and add. That'll give me 390. And then 510, continue the pattern. And then 570. And finally 690. All right, that's what 2x equals. That's not what x equals. So what am I going to have to do to each of these angles in order to get what x equals? Well, I would have to typically divide by 2. So literally, I'm going to divide all of these angles now by 2. So now x equals 15, 30 divided by 2, 150 divided by 2, 210 divided by 2, etc. 330 divided by 2, and you will wind up with 8 angles between 0 and 360. And finally 345. And again, are all of these between my domain of 0 and 360? Yes. So these are all of my answers. All right. Last problem, number 15. I'm sorry, excuse me, number 10. Find all the solutions to each of my equations. Now this is all solutions. So that means once I find my first rotation, remember I have to keep going all around and around and around and around, etc. Okay? So that means I'm going to have to keep adding rotations of 2 pi. So we're going to talk about how we represent that in just a second. But let's go ahead and just solve these how I would typically solve a regular equation. So for this one, notice I have a squared, so you're going to have to get everything on one side, which means subtract these onto the other side. So I'm going to be left with 4 cosine squared a minus 4 cosine of a plus 1 equals 0. And that was just getting everything over to the other side. Now if you notice, this is a quadratic. Okay, for those of you that have a hard time with seeing that, you might want to just say y equals cosine squared a, and that way now your equation is 4y squared minus 4y plus 1 equals 0. That makes it a little bit easier to see the factoring for. Okay, several ways you can factor. You can factor by grouping. You can use the quadratic formula. You can let's see, what's another way? You could do the kind of the simplified method, which I've shown. So I'm going to do that method. I'm going to look for two numbers that when I multiply, I get 4 times 1, which is 4. And when I add, I get negative 4. Okay, those two numbers are negative 2 and negative 2. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is negative 4. So therefore, my 2, I'm going to have negative 2 and negative 2. Make my fractions. I'm going to put them both over a. The a value is 4. And then simplify. So this is negative 1/2, and this is negative 1/2. So notice that my variable goes on the bottom, and I'm left with 2y minus 1 times 2y minus 1. All right, and that's equal to 0. Now what did we say y was? We said y was cosine. I'm sorry, not cosine squared, just cosine. Let me correct that up here. Just wanted cosine, because remember we squared it here. So now I'm just going to say 2 times cosine of x minus 1 times 2 cosine of x minus 1 equals 0. Now since this times this equals 0, I either know that 2 cosine of x equals minus 1 equals 0, or or you can say that 2 cosine of x minus 1 equals 0. Now notice they're the same equation. So if I solve one, I am going to essentially solve the entire thing. So when I simplify this, I'm going to get that cosine of x equals 1/2. So now again, you have to think on your unit circle. Where is cosine of x equal to 1/2? That is at the values of pi over 3 and 5 pi over 3. So the way I'm going to write my answers, I'm going to say x equals pi over 3. Now, I can't stop at pi over 3 because I have to keep going around the unit circle. So every time I go around the unit circle, I'm adding 2 pi. But how many times can you do that? Well, you can do it infinitely many times, or n times. And then also, I have the solution of 5 pi over 3. And again, I'm going to add that value of 2 pi n. And then where n equals 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. Okay? Because you can do that as many times as you want to go around the circle. Okay. Now you could also state these as degrees, so you could say 30 degrees plus 360n, and you could also say 5 pi over 3 or 5 pi over 3 or 330 plus 360n. So either one will work. Okay. So then for the next one, I'm looking at 4 sine squared x minus 3. And for this one, notice I only have a sine squared. I don't have a sine squared and a sine. So I can actually go ahead and add 3 to both sides for this one and take the square root. So 4 sine squared x equals 3. Divide both sides by 4. Sine squared x equals 3/4. Take the square root of both sides. And sine of x, equals plus or minus root 3 over 2. Okay, so again, I'm looking for positive and negative versions. So actually I have 4 different angles that have this value, where sine is root 3 over 2. So the first one is at 60 degrees. And then again, I'm going to add multiples of 360. The second one is in the second quadrant, so 180 minus 30 is 150. Or sorry, sorry about that. 180 minus 60 is 120 plus 360n. Then you want to do 240, which is 180 plus 60 plus 360n. And finally, you do 360 minus 60, which would be 300 degrees plus 360n. Okay, and that's again where n equals 0, plus or minus 1, plus or minus 2, plus or minus 3, etc. All right. You could also write these in radians. You could do pi over 3 plus 360n, 120 instead of 120. You could do 2 pi over 3, 4 pi over 3, and then 5 pi over 3. Okay, if you have any questions, ask one of your teachers.